Wasabi, you guys! Welcome to Integration B Training for Intermediates Part 15. In this section, we will be doing 1 plus sine 2x. Tricks of 1 plus sine 2x. Now, what's so important about 1 plus sine 2x? You might have seen my past videos with it, but here's how the concept works. This is equal to sine of x plus cosine x squared. Now, how is this true? If you square sine of x plus cosine of x, squaring this will give us sine square plus 2 sine of x cosine x plus cosine square. And this is 1. This is sine 2x. Okay? And then for here, either sine of x minus cosine of x, or vice versa, because it's squared. This will become the minus version of this. So this here would be 1 minus sine 2x. Now, the reason why this is such an important concept to remember is because a lot of people in Integration B, especially competitive Integration Bs like MIT, Harvard, or Berkeley, or MathSoc, they will hide this. They will hide this, and you would not know that u is equal to sine plus cosine or sine minus cosine, depending on what the derivative is. They will hide this a lot in the integrals. So it's nice to sort of be aware of this trick. So this is how the concept goes. Alright? So how would you integrate this? The textbook way is to conjugate it, right? We would have to conjugate it, and then you would get something like cosine of 2x over square root of 1 minus sine 2x. Yeah? But I don't want to do that. I would go ahead and square it. I would substitute this. Oh, this is sine x plus cosine x squared. The square root gets canceled out, so now this integral is just sine of x plus cosine of x. So now this is just sine of x minus cosine of x plus c. And that's it. I'm done. That's all I have to do. In fact, you could even do this in your head, and it would be that quick. Okay, what now? So, if you try to do trig manipulation, it's gonna be horrific. It's not fun. It is not fun if you try to do any trig manipulations with this. So, then what on earth do we do here? We use the 1 plus sine 2x trick. It's hard to see at first, but you'll start to get the hang of this. So, I noticed that this is cosine x minus sine of x, and I see there's some type of sine 2x here. Ah, there's something. There's a 1 plus sine 2x trick here. Okay? So let's go ahead. The first thing I would do is multiply top and bottom by 2. So I'm just going to write the 2 here. Abbreviate. And the reason why I want 2 at the bottom is just to get that sine 2x. And so now we have 2 plus sine 2x. Now, notice that cosine minus sine of x, I want that to be my du. If du is going to be cosine minus sine of x, then I would want u to be what? Sine plus cosine. This is how you determine whether you need 1 plus sine 2x or 1 minus sine 2x. Okay? So now I see that we need sine plus cosine, so I'm going to need a 1 plus sine 2x. Perfect. Because I could just have that. 1 plus sine 2x. 1 plus sine 2x is equal to s plus c squared. Now you can let u equal sine plus cosine, and this is just du 1 plus u squared. Would you look at that? Now this whole integral is just 2 times the inverse tangent of sine of x plus cosine of x. And that is our answer. That was a very bad box. But there, oh my god. What is wrong with my hand? There we go. That's our answer. See, so very simple. Sometimes it's not so clear in a lot of advanced types, but we'll definitely go through that. Oh boy, here is a very good one. This is a very good one that kills a lot of competitors. So this one, what would you do? So I see cosine x minus sine of x, and I see sine 2x. There's a 1 plus sine 2x trick here. Okay, so I see that my du, I would want my du to be cosine minus sine. So that means that I need to do s plus c. And that's pretty, I find u just by integrating this pretty much. So this means that I need a 1 plus sine 2x. You got it. So I'll have to do plus 1 minus 1. That's what that is. So now our integral is going to be, well, let me write it like this. Uh-oh, I didn't mean it like that. I cannot undo. Oh, there you go. Minus 1. Okay, so that's what we have. So then our u is this. We get u squared minus 1. I'm too lazy to do trig substitution, so I'm just going to use inverse cosh to make it faster for myself. So inverse cosh sine of x plus cosine of x plus c. And that would be my answer. Definitely faster than the timer or the opponent. It's very nice. Oh god, okay. Don't freak out. Do not freak out. Don't freak out. What on earth do we do here? Now, you're probably seeing this and you're like, oh, I'm having flashbacks. It's one of these ugly engineering integrals. Calm down. Calm down. Let's turn this in terms of sine and cosine. And we see that this is like SC, S plus C. Ooh, what does this look like? What does this look like to you? It looks familiar, right? So I want my du to be S plus C. Then my u has to be what? Sine minus cosine. So then that means we have to we need 1 minus sine 2x. That's what that is. Okay. So I'm going to need 1 minus, oh, well, first of all, I need a square root of 2. So that I can get the square root of 2 here. And now it's sine 2x. So now it's sine 2x. And then I'm going to do minus 1 plus 1. So now what that would look like is now it would look like this. This, again, we need 1 minus sine 2x. So it would look like 1 minus sine 2x. That's what this would look like. Okay? And now this becomes sine minus cosine squared, because that's what we need here, right? So now this is just root 2 of du square root of 1 minus u squared. Oh, wow, would you look at that? This is just root 2 of the inverse sine of u sine x minus cosine of x plus c. Oh god. We have reached the G-main territory. What is this? Oh god. What do we do here? This looks nasty. Let's see. I don't like that secant x. So cosine of x 1 plus sine of x cosine of x. What do we do here? I'm lost. I can't apply 1 plus sine 2x trick here. So what do I do? Okay, well technically, yes you can. It's just very hard to see. So, just pay very close attention to what I'm gonna do, alright? I'm gonna do a half times 2 cosine. Okay? So, pay very close attention. Why am I doing this? I need 2 cosines. I need 2 cosines so that I could do a cosine plus cosine. And then I'm going to do a plus sign minus sign. And the reason is because I can utilize 1 plus sine 2x or 1 minus sine 2x. So it'll come off with a bunch of this plus u square or this minus u square, right? And that's easy to work with. We know how to work with that. Inverse tangent and inverse tangent. You need to have times 2 here. Okay, so we're gonna have to multiply. Oh, I'm sorry. We have this half. We already have this half. So this half is gonna help us. This half, we're gonna utilize this half. We're gonna utilize this half and get 2 plus 2 sine cosine of x. Okay, now what we have here is 1 plus sine 2x, right? And then here we need a minus 1. We need a minus 1 here. So minus 1 plus 1, 3 minus 1 minus sine 2x. Right. And the reason why I have to format like this is because this was positive. And I need it to be negative. So because I need it to be negative, I need to put a minus here. Okay? And now that we got that covered, we can go ahead and do our u-substitution. Here we have our u here is sine minus cosine. Our w here was sine plus cosine. Okay, just a reference here. All right, now we're going to go ahead and integrate. This is now du. This is not u. It's du 3 minus u squared plus dw of 1 plus w squared. Now this is easy. This is just 1 root 3 inverse tangent of u over root 3 plus inverse tangent of w. And so now our answer is just inverse tangent. This was sine of x minus cosine of x over root 3 plus the inverse tangent of sine of x plus cosine of x plus c. That was nasty. So this here, approaching here to here is the hardest part. Not that many people can see this. This is very difficult to see. This is a G-main technique, actually. So transitioning here to here is very difficult to see, and then realizing that you can utilize 2 cosine of x to make c plus s and c minus s to make 2 different variations of the squares, 1 minus sine 2x and 1 plus sine 2x. So this is our last integral, and this looks very horrifying. So what can I do with this? Well, I want to turn this into a bunch of sines and cosines first of all. So we get what? 1 plus, I'm just going to write it like this. This is cosine minus s minus s over c. This is actually square root of sc, c minus s. Okay. So that's what we have with this. So we have 1 plus sine 2x. We have cosine of x on top. Okay, so because of this, I know for sure that we're going to be using 1 plus sine 2x. I'm sorry, that's incorrect, no. Sine of x plus cosine of x. There you go, that's what I meant to do. So we know that we're going to use this substitution because of this numerator, right? But what are we going to do with this? What are we going to do with this? Let me show you. We're going to deal with this by using our u. So this is another very tricky technique to see. So we're going to u square. Our u square is what? 1 plus sine 2x, right? Then sine 2x, well, this is pretty much sine 2x, but without the 2. So u square minus 1 divided by 2, this is sine x cosine of x. Aha! So our integral, well, plug in 0, we get 1. Plug in pi over 4, we get root 2. So now we have our du, 1 plus sine 2x. This is u square. But then what's in here? What is this? This is u square minus 1 over 2. Okay. There you go. So now what? Now, let's see, this root 2 gets to put on top. Root 2 du, u square over, I'm sorry, u square with square root of u square minus 1. Ah! It's a trig sub. It is a trig sub. Let u equal secant theta. Awesome. I don't mind this at all. From 1 to root 2, this becomes secant theta, tangent theta, d theta, and then we get secant square here, and then we purposely made this as tangent theta. Everything cancels out except, oh, would you look at that? How beautiful. This is just cosine theta, d theta, which is equal to sine theta. That's all we care about. I realized, wait a minute. Oh, I forgot to put in my bounds. I was like, wait a minute, something's not right. I forgot to put in my bounds. Okay. So, thank goodness we checked. So, here, plug in inverse secant of 1, because you want 1 equals secant theta. Then that's going to be what? 1 plus cosine theta. We need this to be 0. So we have 0 here. Awesome. And square root of 2, that's pi over 4. Oh, wow. That is amazing. root 2 over 2. Wow, so this whole thing is equal to 1? Is it really equal to 1? Is it really? What? This whole thing's equal to... Hold on, wait. Oh my god. This actually equals to 1. That's... nice. Holy hell. Well, there you go. Wow. Okay. So that's about it. That's all the 1 plus sine 2x tricks that you need to know. Yeah. That's pretty much it. So hopefully you find this very helpful. You might come across this in a competitive integration bee. Sometimes. But it'll definitely be somewhere. Probably like in a qualifying exam or semifinals. But very, very useful for nasty trig integrals. So thank you so much for watching, and I'll see you guys in the next section.